and I'm going to explain to you today one of the weirdest things about quantum mechanics, which is the uncertainty principle. A lot of people get weirded out by quantum mechanics because it doesn't relate to their life. Well, that's actually not true with the uncertainty principle and a lot of the other things about quantum mechanics. So today, for all you aspiring sci-fi authors, science fans, and students, I'm going to teach you a little bit about the weirdness of quantum mechanics and show you how your life is probably just as weird. In doing so, you'll come to understand the principle a little bit better. What is the uncertainty principle? Well, in science, a lot of times we deal with waves. And quantum mechanics is when we take things that we thought were just specks of matter and we turn them into so-called matter waves. And it's a really neat principle. You're going to love it. We'll talk about it next time. But for now, let's just focus on the interactions of waves themselves. Let's say a reporter reports on an incident that happened in Alaska. A tsunami hit the Alaskan coast at 5 a.m. this morning. Some wise guy walks up to the reporter and says, "What frequency was that wave?" Who's the idiot, the reporter or the guy who asked the question? Well, really neither of them. That wave that hit the Alaskan coast doesn't have a frequency. There was just one of them. So the question was really irrelevant. That's what the uncertainty principle is. It's just the irrelevancy principle. Sometimes, for certain waves, certain questions just don't have an answer. And that's okay. So when we mathematically formulate the uncertainty principle, we say, this aspect of something and this aspect of something, they're in different situations, can be more or less meaningful. But the product of those two things is constant. When one thing becomes very well resolved, the other thing becomes very unresolved, and so on. Sounds kind of strange. Really isn't too bad. Let's look at a single wave. If I have a wave of a defined frequency, I can take a bunch of waves with locations in space and put them together, and I can define a single frequency. Many waves define a single frequency. On the other hand, I can take a bunch of frequencies, put them into a speaker, and I can get a big beat that comes out of it. Wah, wah, wah. And every time that beat comes through, there's a well-defined sound amplitude in time. There's a big peak, right? So I can take many frequencies, put them together to create a single wave. So frequencies define a single wave, and many waves together make a single frequency. And just as we discussed in Alaska, where a single wave doesn't have a frequency associated with it, if I have a wave that goes on forever, it doesn't have a location associated with it. Let's take a step back and talk about your life. If you've been to high school and had 10th grade English class, you've probably been assigned to read a bunch of books you didn't want to read. Some of those you might have even liked. As you read the book, it gave you a great feeling, or it made you think about the world differently. But then you go to class, and your teacher starts lecturing about all the literary, really in an effort to help you appreciate the book. She starts diving into the literary devices, the scene structure, the analogies, the irony, and all these sorts of things. And by the time the teacher is done helping you appreciate the book, you hate it. You can't stand it. And that feeling that you had when you read the book without thinking about it is gone. What's happening is the uncertainty principle. In order to create a feeling, the author uses a variety of devices. Those devices, taken together and unresolved, point and create that single feeling. On the other hand, if I just pick one aspect of a book, like a scene or character development or other things like that, it's going to have a lot of different emotions associated with it. So what you have by resolving individual literary devices are unresolved feelings. And that's okay. That's just life. So read your books, enjoy them, but know that if you try to dissect them, they're not going to create the same feeling they do when you just read it like the author intended you to. Feelings, on the one hand, and literary devices on the other are non-commuting variables. Two ways of describing the same thing. Let's talk about investments. Each of us, if we have money and want to make more, need to invest our money. So we have a choice about where to invest. If I invest in a particular company, it's got a collection of risks associated with it, whether it's sensitive to a downturn in Asia, or a downturn in the tech economy, or a change in oil prices. If I pick one company, I get a whole collection of risks associated with it. If I want to isolate a particular risk, like if I was creating a hedge fund or a mutual fund, I can look and I can get a collection of companies where each of them, although some of the risks may be different, share a common risk. And there I've maximized or minimized the risk to a particular aspect of the economy. One company is defined by a collection of risks. On the other hand, a collection of companies can resolve a single risk. Non-commuting variables, just like time and energy or position and momentum in quantum mechanics. You've heard the phrase, the clothes make the man? Well, they kind of do. If I was to go out and lay out all the clothes from a single person's closet, we could probably narrow that down to one person in the US. On the other hand, if I pick a single shirt, I'm going to isolate a whole bunch of different people. So, clothes and people are non-commuting variables. One person defines a collection of clothes, and one piece of clothing is defined by the intersection of a collection of individuals, just like quantum mechanics. So that, my friends, is a little bit about the uncertainty principle. You can play a chord on the piano, and you can get, it's made up of a bunch of keys, or you can overlap a bunch of chords to identify a single key. There's lots of these analogies all around the world around you, and you can use them to help understand and appreciate the uncertainty principle. And next time, we're going to learn about the math behind it. No math, just pictures. It's going to be a lot of fun. We're going to do integrals, we're going to do convolutions, and we're going to do Fourier transforms, all to help you understand how we change from position to momentum space and begin to appreciate uncertainty in waves. And after that, we're going to dive into matter waves, which is going to blow your mind. See you next time.